Magnets. They're more than just colorful toys or things that stick to your fridge. They possess an invisible force, a power that has fascinated humankind for millennia. But how do they work? What is this mysterious force that attracts and repels? Let's unravel the magic of magnets. We've all played with magnets, experienced the invisible push and pull. This seemingly simple phenomenon is actually a fundamental force of nature, just like gravity. Understanding magnets means understanding a key part of how our universe functions. The secret to a magnet's power lies within its smallest parts, atoms. Each atom contains electrons, tiny particles that spin and orbit the atom's nucleus. Imagine these electrons as tiny spinning tops, each generating a miniature magnetic field. In most materials, these atomic magnets point in random directions, their magnetic forces canceling each other out. This is why your wooden desk doesn't stick to your metal stapler. But in magnets, something amazing happens. Within a magnetic material like iron or nickel, these atomic magnets group together in regions called domains. Think of domains as tiny neighborhoods where all the atomic magnets point in the same direction. When a material is not magnetized, its domains are randomly oriented. However, if you expose it to a strong external magnetic field, something fascinating occurs. The domains begin to align themselves with the external field. It's like all the tiny compasses within the material suddenly decide to face the same way. This alignment of domains creates a net magnetic field around the material, turning it into a magnet itself. This is how we make magnets. Now this magnet has two poles, a north pole and a south pole. Remember those spinning electrons? Their combined spin direction dictates the north and south poles. Here's where it gets interesting: opposite poles attract, while like poles repel. It's this push and pull that makes magnets so fascinating. Section 5. Mapping the magnetic field. We can't see the magnetic force, but we can visualize it using magnetic field lines. These invisible lines flow from the north pole of a magnet to its south pole, creating a three-dimensional map of the magnetic force. The closer the lines, the stronger the magnetic field. Iron filings sprinkled around a magnet beautifully illustrate these lines, creating a visual representation of the invisible force. Section 6. Earth, a giant magnet. Believe it or not, our Earth itself is a giant magnet. Deep within Earth's core, molten iron flows, generating electric currents. These currents, in turn, create a magnetic field that surrounds our planet. This magnetic field acts as a shield, protecting us from harmful radiation from the sun. It's also the reason why compasses point north. The compass needle aligns itself with Earth's magnetic field lines, guiding explorers and adventurers for centuries. Section 7. Types of magnets, from lodestone to electromagnets. Magnets come in various forms, each with unique properties. Lodestone, a naturally occurring mineral, was the first magnet discovered by humans. Today, we create different types of magnets for specific purposes. We have permanent magnets like the ones on your fridge, which retain their magnetism for a long time. Then there are temporary magnets like paper clips that become magnetized when near a strong magnet but lose their magnetism quickly. And let's not forget electromagnets, whose magnetism can be turned on and off using electricity. Section 8. Magnets in our lives, silent helpers. Magnets are more than just fascinating objects, they are essential to our modern world. They power our speakers, store data on our computers, and even help us generate electricity. From the simple compass to complex medical imaging devices like MRI machines, magnets are silent helpers in countless aspects of our lives. They are the unseen force behind many technologies we rely on every day. Section 9. The future is magnetic. The study of magnetism is far from over. Scientists are constantly exploring new ways to harness the power of magnets, from developing faster and more efficient computer storage to creating novel medical treatments. As we delve deeper into the mysteries of magnetism, who knows what incredible applications we will discover. One thing is certain: the future of magnets is bright, filled with exciting possibilities that could revolutionize our world.